Now let's learn how to calculate the area underneath a curve. Here's the curve of y equals x squared. We'd like to calculate the area underneath the curve, above the x-axis, between x equals 1, and x equals 3. The area is marked in red. To calculate the area, we divide x in equal intervals. Here we use 8 intervals. Each x hits the curve at y. This forms 8 rectangles. We can estimate the area with the sum of all these rectangles' areas. As the number of intervals increases, each rectangle gets smaller and smaller, and the sum of all rectangle areas gets closer and closer to the area underneath the curve. We mark the area of each rectangle as delta A, because it's small. The total area A is the limit of the sum of delta A, for x from A to B, when delta A approaches 0. Let's look at delta A. The width is delta x. Since each x hits the curve at y, the area delta A is y times delta x. So A is the limit of the sum of y delta x for x from A to B, when delta x approaches 0. Therefore, y is the limit of delta A over delta x when delta x approaches 0. This is dA over dx. If y is dA over dx, then A is the integral of y dx. So the area underneath the curve, above the x-axis, between x equals A, and x equals B is the integral of y dx from A to B. The integral of y dx from A to B is called definite integral. It has two limits. A is the lower limit, and B is the upper limit. The result of a definite integral is a number. The result of an indefinite integral is a family of function with plus c. They are different. Now let's see how to calculate the value of a definite integral from an example. Find the integral of 3x squared from 1 to 3. We still integrate 3x squared and get x cubed, but we don't write plus c. Instead, we put x cubed in squared brackets, and put the two limits on the right side. Then we calculate the function values of the two limits, and subtract them. Put 3 in x cubed, we get 3 cubed. Put 1 in x cubed, we get 1 cubed. So the result is 3 cubed minus 1 cubed, which is 26. The result is fb minus fa, where f is the integral function. Here's another example. Find the integral of 1 over root x from 1 to 4. 1 over root x is x to minus half. So the integral of 1 over root x is 2 root x. Put 4 and 1 in it, we get 2 root 4 minus 2 root 1. The result is 2. In this class, we learned the definite integral has two limits, a and b. You do the integration as usual, but put the limits in the integral function, and calculate their difference. The area bounded by the curve f of x, the x-axis, x equals a, and x equals b, is the integral of f of x with respect to x from a to b.